Okay, so 8B, I'll just make sure this is focused. There is a slow reaction here, it seems. I think the system is slow. Okay, here's 8B on page 7. Okay, 8, I'll do 8 first. Well, a game consists of tossing 2 coins. If the result is 2 heads, you win $1. Okay, so let's just see. Head, tail, head, tail, head, tail. So if the result is 2 heads, you win $1. If the result is a head and a tail, you win 50 cents. If the result is 2 tails, you're down $2. What is the expected value of this game? Okay, so you would go expected win is equal to a quarter times $1 plus a half, right? A quarter cents. So it's going to be 1/2 of 50, and then it's going to be minus 1/4 times $2. And so the expected win on this first one, I realize I'm doing part A first, just to get used to the question. So 0.25 plus, well, 0.25 plus 0.25 minus 0.5. Oh, 0. Is that right? Is that 0? Yeah, it's really slow. It's not, here B. Okay, here's B. For the game to be fair, what should you lose on the toss of 2 tails if you win $3 for 2 heads? So, for the game to be fair, expected win should equal 0. So we want for the game fair, expected 0 equal $3, so that's a quarter for 2 heads, and $2 for a head and a tail, so it's plus 1/2 times. So what should the loss be? So minus 1/4 times. What should you lose on the toss of, just put it, should lose. It's so slow. I don't know what, is this slow up there? It is, yeah. Okay, so we need to solve for this. So 0 equals 3 times 0.5, and I get 0.75. $1 minus 1/4 to L. It'll be minus 1.75 equals, right, I added them up, I subtract, equals negative 1/4 times the loss. So the loss should be $7. Makes sense. Yeah, you could. Whatever you prefer. Oh, well, it's just that I added up with the negative. Our loss should be 7. If I put a positive, loss would have been a negative. So whatever. Either way, our loss should be $7. So if you express it as the loss should be $7. Were there any other homework questions? Okay, let's do 13. Number 13. A tetrahedral die with 4 faces is weighted, so the probability of land is directly proportional. So 1, 2, 3, 4. So the probability, the total is 7, 8, 9, 10. So it's proportional. So the probability of this is 1 over 10, 2 over 10, 4 over 10. That's what they mean by it's proportional. It's according to the number on the face. So yeah. Okay. So then it asks us the ability for the die. Find the expectation. The expectation be expected value x 1 times 1 over 10 plus 4 over 10 plus 9 over 10 plus 16 over 10. So that's 5, 14, I guess 3. Is that the right answer? Is the value 3? Okay. Was there anything else? United Insurance Company has analyzed its claims. What premium should the insurance company... Okay, what's the expected payout from 12A? Sorry? That's the answer for the expected pay. 12. They want a 30% more. Do we just multiply by 1.33 or do we add 0.33? And you got the right answer? Yeah, that's true. It's the profit, so
that's the expected payout right now, but they want a 33.33% margin on top of that, so you have to increase that value by 30.
yeah. You have to know accounting. He's our accounting expert.
She's in my accounting class too. We're not even doing this.
Okay, anything else? Okay, let's do it. It's not a long lesson for uniform. It's kind of one of the easier distributions. The simplest probability distribution is the one in which each outcome is equally likely. An example of this situation is the rolling of a single die. Each outcome has probability 1 over 6, okay? So the probability x equals 1 or the probability x equals 2, like they're all equal. Probability x is 1 equals probability x is 2 equals probability x is 3 equals probability etc., etc. They're equally likely. That's what a uniform distribution is. Distributions that, oh, here's a sample graph. Don't worry, on a test I won't ask you to graph, but for each value on a die, the probability is 1 over 6, which is a little bit above 0.15. Distributions that have the characteristic that each outcome is equally likely are called uniform distributions. General distributions are defined as the probability of any value is 1 over n, where n is the number of outcomes. So example, if you have a 12-sided die, the probability x equals any value, that there's 12 outcomes, so it's 1 over 12, where x is the element of 1, 2, 3, all the way up to 12. Okay? They're just equally likely. Nothing to get excited about. Nothing, nothing, nothing. Yeah, nothing to get excited. I think I've got the wrong book. All my books have writing already, but oh, thank you. A woman has 16 units of framing to enclose a rectangle. The width of the is chosen randomly and only integer widths are to be chosen. What is the expected width of the rectangle? What is the expected area of the rectangle? Okay, let's take a look at this. She has 16 units of frame plus 2 equals 16 rectangle. L plus W is equal to 6. The width, oh, equals 8. That's right. Thank you. Here's our width. Here's our length. We're going to do probability of width. Calculate our widths. Well, they tell us only integer widths are to be allowed, so the lowest width it can be is 1. If the width is 1, then the length must be 7. If the width is 2, the length must be 6. If the width is 3, the length must be 5. 4, 4, 5, 3, 6, 2, 7, 1. Well, there are 7 possible widths, and we're working with it that it's equal probable. So this is going to be 1 over 7, 1 over 7. The probability of each width, 1 over 7, 1 over 7, 1 over 7, 1 over 7. So the width times the probability of the width is 1 over 7. 2 times 1 over 7 is 2 over 7. 3 over 7. 4 over 7. 5 over 7. 6 over 7. And 7 over 7. So our expected equal to the sum of WPW, and that is 28 over 7 equals 4. 4 units. Okay, let's just maybe squeeze in a column for area. Okay, and I'm going to squeeze it in there for the area. This area is 7, 12, 15, 16, 15, 12, 7, right? I just put our area right in there. Just put it in wherever you have room. Okay, and that was 1 over 7. Okay, so let's do our expected area. So we'll do let A equal area. And then we'll do the probability of each area. And we'll go from there. So we could have an area of 7, 12, 15, 16. There's 4 different areas. The probability of getting an area of 7 is just no, they're a little bit different. 7 is 2 over 7, right? Because you have this one. Yeah. And then for 12 is 2 over 7. And then we have 2 over 7. For 16 we have 1 over 7. So it's not uniform, right? Area is not a uniform distribution. But we can still go ahead and calculate our expected area. Okay, so we'll do AP of A. So this is going to be 14 over 7, 24 over 7, 37, 16 over 7. So our expected area is equal to the sum of AP, well, whatever that A value is. Sometimes they put capital A or little a, whatever, is equal to the sum of, oh, I already wrote that. The sum of these guys is 84 over 7, and that equals 12 squared. Jumpy today. Can I explain anything better? It's pretty straightforward, yeah?
If a group of data perform uniform distribution, then there's the expected value of the
Well, expect value and value.
that's the average that group of data has.
Oh, I see what you mean.
So
Well, let's see. Yeah, if it's uniform, if we were to add these up and divide by 7, what would we get?
it's
Oh, okay. Yeah,
because
because it's all equiprobable.
theoretically, so the other distributions are unweighted. Weighted, this is unweighted. That's why
Yeah.
it's weighted as factor.
They all have equal weight. Yeah.
Yes.
Yeah. Okay.